Hello everyone, welcome to Sri Black's Fun and Edutainment channel. We are providing education with entertainment. Right? In the previous video, we have discussed some important long answer questions on Unit 1, especially from Part 1. In today's video, we will discuss some more problems on Part 1. Let's dive into our topic. Right? See here, check f of z equal to z plus 2z bar is analytic or not. So this is very simple question. We will do it now. F of z is equal to z plus 2z bar. So the given function, what is the given function here? Given that f of z is equal to z plus 2z bar. So here also the function is given in terms of z. When the function is given in terms of z, the step number 1 is convert it into the form u plus iv. Yes. So step number 1. First we convert this into the form u plus iv by substituting in the place of z x plus iy. Now our f of z changes to, in the place of z we can substitute x plus iy. Now here z bar. What is this z bar? Yes, we aware of a complex conjugate. Z bar is nothing but conjugate of a complex number. Conjugate of a complex number is denoted by z bar. So if z is equal, we learned in our intermediate level, if z is equal to x plus iy, then z bar is equal x minus iy. So replace the sign in front of the imaginary part with opposite sign, then we get the conjugate of the complex number. So here z bar denotes the conjugate of the complex number. Here, so z is equal to x plus iy, then we know that z bar is equal to x minus iy. Okay, these are the basics you have to know. We learned it in our intermediate level, complex numbers. We learned in intermediate level it is called complex numbers. Just we learned all about complex numbers. In our M4 we are learning complex analysis. Complex analysis is nothing but differentiability, integrability, and the power series, and some transformations of complex transformations of functions. All this is called analysis. Okay, so z bar is equal to x minus iy. So here in the place of z bar we can substitute x minus iy. So here f of z is equal to x plus iy plus 2z bar, right? So 2 into x minus iy. Now we have to change it as real and imaginary parts. What is the real part here? X plus 2x. So clearly x plus 2x can be written as 3x plus I into y minus 2y. If we take common I from the imaginary parts, here it is I. So what is the remaining here? Y. And here what is remaining? Plus into minus 2 into y, 2y. Y minus 2y. So that we can write it as 3x plus I into y minus 2y is nothing but minus y. So this is the step number 1. Now it is clearly of the form u plus iv. Okay, now coming to the step number 2. What is in the place of u? Right, u is equal to 3x. What is in the place of v? V is equal to minus 1. Now step number 3, we move to the step number 3. What is the step number 3? We have to find the partial derivatives of u with respect to x and y, as well as partial derivatives of v with respect to x and y. Now in step number 2, we are finding dou u by dou x. That is dou by dou x of 3x. Dou by dou x of 3x. So here we are differentiating 3x with respect to x. So here it is x and here it is also x. X match. So 3 is a constant. So 3 into dou by dou x of x value is nothing but 1. Okay, that is equal to 3. This is equal to 3. And dou u by dou y. Dou u by dou y. Dou by dou y of 3x. Okay, so observe here we are doing differentiation with respect to y, but here it is x. Here it is y. Here it is x. Is the terms match? Yes, not match. That means if the terms are not matched, means it is a constant. So dou by y of 3x. 3x is nothing but a constant. Okay. So what is the differentiation of constant? Right, exactly. 0 is the differentiation of constant. Clear? Now in the same manner we do the differentiation for v also. Dou v by dou x. So minus is the constant. Dou by dou y of y. So dou by dou y of y is nothing but 1. With respect to y, differentiation of y is 1. Clear? Dou v by dou sorry, here it is dou v by dou x. We are doing differentiation with respect to x. Okay, so here we are doing with respect to x, here it is y, so the differentiation of constant, y is treated as constant, so 0, clear? Okay. So dou v by dou y, that is equal to dou by dou y of minus y. Now minus of dou by dou y of y is nothing but minus 1. Dou by dou y of y is the value of dou by dou y of y is 1. Here, so we got all the values, dou u by dou x, dou u by dou y, dou v by dou x and dou v by dou y. Now step number 3. What is step number 3? You have to verify Cauchy-Riemann conditions only, because so clearly the given function is a single valued function and partial derivatives. So the second condition is all the first order partial derivatives should exist. That means already we are finding here partial derivatives. Okay, so that if the partial derivative values are some fixed values or some finite values, then it means that partial derivatives are exist. That means second condition is by default exist. Okay, now we have to check CR conditions. CR conditions. If CR conditions is satisfied, then it is analytic. Otherwise, it is not analytic. Now, so dou u by dou x. The first condition CR conditions are dou u by dou x equal to dou v by dou y. What is our dou u by dou x? 3. But what is the dou v by dou y? Minus 1. So clearly dou u by dou x is not equal to. So because dou u by dou x is equal to 3 and dou v by dou y is equal to minus 1. So dou u by dou x not equal to dou v by dou y. Okay, so first condition fail. If first condition fail, then there is no need of going to the second condition. Okay, so if the function has to be analytic, both the conditions must satisfy. First and second conditions must satisfy. Here first condition fail, that means Cauchy-Riemann equations are not satisfying. Therefore, f of z is not analytic. F of z is not analytic. Clear? So if this type of problems are asked for 10 marks, it is very easy to do. So please observe that. Just you have to verify Cauchy-Riemann conditions. So here Cauchy-Riemann first condition failed, therefore the function is not analytic. Next question. Check f of z equal to e power z is analytic or not. If analytic, find its derivative. Okay? Right. So what is given function here? F of z equal to e power z. So similar to the previous problem, here also the function is given in terms of z. If the function is given in terms of z, our step number 1 is to substitute in the place of z x plus iy and have to convert it into the form of u plus iv. So we are substituting in the place of z x plus iy, so that f of z is equal to e to the power x plus iy. Now here e power x plus iy, we are having the formula. If a to the power of m plus n is there, we can write it as a power m into a power n. That means if bases are equal, we can add the powers. Using that principle, we can write here e power x plus iy as e power x into e power y. Okay. Now what is the real part and what is the imaginary part here? Or can we express it as u plus iv? Is it in the form of u plus iv or not? No. Yes. Clearly it is not of the form u plus iv. Then what to do? So if you want to convert this expression into u plus iv form, we need to know the formula for e to the power iy. That means we have the formula in complex numbers. E power I theta is equal to cos theta plus I sin theta. Okay, you need to remember this formula. E to the power I theta is equal to cos theta plus I sin theta. Okay, so here what is in the place of theta? Y. So e power x into cos theta plus I sin theta. That means cos y. In the place of theta, here it is y. So that cos y plus I sin y. Cos y plus I sin y. It can be written like this. Now this is equal to, now is it in the form of u plus iv? Yeah, it is closer to the form u plus iv. Now we can change this into u plus iv by multiplying this e power x to the internal terms. Now e power x into cos y. Okay, e power x into cos y plus, you should multiply this e power x to the second term, then what we get? I into e power x into sin y. Right. Now if you observe, so this is of the form u plus iv. This is the real part and this is the imaginary part. Now it is clearly of the form u plus iv. Now compare this expression by u plus iv, then we get u and v. Now the step number 2 is finding the first order partial derivatives of u and v. Okay. So clearly we have u is equal to e power x into cos y. V is equal to e power x into sin y. Okay. Now what we have to find? Dou u by dou x, dou u by dou y, and dou v by dou x, dou v by dou y. Now first we are finding dou u by dou x. That is dou by dou x of e power x into cos y. So already you know how to do the partial differentiation in the previous problems. So I think now it is easy to do for you. So here clearly x is there, here x is there in this first function. In the second function x is not there. That means terms are not matched. If the terms are not matched, it is treated as constant. That means cos y treated as constant. So when doing the differentiation, we have to take out the constant and to do the differentiation for the function only. Now cos y is constant. So we are taking out the constant cos y and doing the differentiation for e power x. Okay, what is the differentiation of e power x? Okay, you should know the formula of differentiation. So the basic formula, at least the basic formula you have to know. Okay, there are 26 basic formula. I will give the formula for you, but just remember in the problem e power x. So here what is e power x differentiation? Yes, exactly, e power x differentiation is e power x only. Okay, so cos y into e power x. Now with respect to y, in short form we can denote it as ux. Now taking u and differentiating with respect to y, dou u by dou y, dou y of e power x into cos y. Now if we observe, here y is there, here x is there, so not matched variables, not matched, therefore it is a constant. Taking the constant out, you have to differentiate the variable y with respect to y. So the function in variable y, dou by dou y of cos y. Right, what is the differentiation of cos function? Right, exactly, minus sign. Differentiation of cos function is minus sign. Please remember, I am explaining the formula in the along with the problem only. Okay, so please remember that cos differentiation is minus sign. So minus sin y. So it can be written as minus e power x into sin y. Dou u by dou x is over, dou u by dou y is over. Now coming to v, here also we need to find dou v by dou x. So dou by dou x of e power x into sin y. So here x is there, here x is there, so the variables are matched, and here x is there, here y is there, so variables are not matched, so you have to take common that sin y function and do the differentiation for e power x. So sin y into dou by dou x of e power x. So sin y into dou by dou x of e power x is e power x. Okay, so vx, it is a short form. In short form, it is denoted by vx. Now coming to with respect to y, dou v by dou y, dou by dou y of e power x into sin y. Now with respect to y, we are doing the differentiation. So y, here it is y matched and e power x is constant. So e power x taken out and dou by dou y of sin y. Now what is the differentiation of sin y? Right, exactly, the differentiation for sin function is cos. So cos y, so this is say vy. So we found all the partial derivatives, first order partial derivatives ux, uy and vx, vy. Now we have to check the CR conditions, because the given function is clearly single valued function and the partial derivatives also finite. So dou u by dou x existed, dou u by dou y is also existed, dou v by dou x is existed, and dou v by dou y is also existed. That means second condition is default satisfied. So we move to the third condition. If third condition satisfies, then this function is said to be analytic, otherwise it is not analytic. Okay, clear? Now if you observe here, what is dou u by dou x? Cos y into e power x. It should be equal to dou v by dou y. Then we observe this. So cos y into e power x, vy. Okay, this is ux, and this is vy. Are you observing? So what is this? Cos y into e power x. What is this? Cos y into e power x. Both are equal, right? Now what is the next condition? Dou u by dou y is equal to minus dou v by dou y. That means dou u by dou y and dou v by dou y must have, sorry, dou v by dou x. Okay, dou u by dou y and dou v by dou x must have opposite in sign. Opposite in sign. So if you observe here, dou u by dou y is there. So minus e power x into sin y, and here vx dou v by dou x is there, plus sin y into e power x. So if you observe these two, so they are numerically equal. Sin y into e power x is here. Here also sin y into e power x, but it is opposite in sign. Okay, clear? Here ux or dou u by dou x. Ux is equal to cos y into e power x. Cos y into e power x. It is clearly equal to vy. So condition A satisfied. Now uy is equal to minus e power x into sin y. Okay, so it is clearly equal to minus vx. Sin y into e power x we can write as vx. So second condition is also satisfied. Therefore, given f of z is analytic function. F of z is equal to e power z is analytic function. So here one question is also there, extension question is also there, that is, if it is analytic, find also its derivative. Okay, if the function is analytic, then it is differentiable. So we can find a differentiation by applying normal differentiation rules only. Okay, now we are doing differentiation with respect to z on both sides of this function. So d by dz of e power z. So d by dz of e power z is nothing but f of z is nothing but f dash z. So here d by dz, z is z, match. So what is the differentiation for e power x? E power x only. So e power z with respect to z differentiation is also e power z. So this is the differentiation of the given function e power. Let's discuss this problem. Check f of z equal to sin z, analytic or not. If analytic, find its derivative. Right, as usual, step number 1. What is the step number 1? In the place of z, we have to take x plus iy, because the given function given in terms of z. So that f of z is equal to sin of x plus iy. Is it in the form of u plus iv? Can we separate this as u plus iv? No. Then what should we do? Yes, we have to apply the formula for this, that is sin of a plus b formula first. Sin of a plus b. So we know sin of a plus b formula in our 10th level. Sin of a plus b is equal to sin a cos b plus cos a sin b. Sin a plus b formula is sin a cos b plus cos a sin b. Please remember that formula to convert it into the form of u plus iv. Now what is in the place of a here? X. So what is in the place of b here? Iy. Okay. Now by using the formula, we are expanding this sin a, sin x, cos b, cos iy plus cos a, cos x into sin b, sin iy. Clear? Now sin x into cos iy plus cos x into sin iy. So here there is no imaginary part particularly. So sin x into cos iy plus cos x into sin iy. But in the cos function angle it is iy. In here sin function angle iy is there. So you should remember one more formula here. So when in the cos function angle I is there, there is a formula. You must remember it. You must remember these two formulae. Cos iy is equal to cos hy. Cos hy. So cos imaginary of y is equal to cos hyperbolic y. Please remember. And sin iy. Sin iy is equal to I sin hy. I sin hy. Okay. So for cos function, if iy is there, it changes to directly only hyperbolic y. Hyperbolic y. In sin function, I is there, so it changes to sin hyperbolic y with a multiple of I. with a multiple of I. Okay, you should remember these two formulae to convert it into the form of u plus iv. So from that formula we can write sin x into cos iy is nothing but cos hy plus cos x into sin iy is nothing but I sin hy. So we can write it as sin x into cos hy plus I into cos x into sin hy. Okay, now observe this. It is clearly real part, it is clearly the imaginary part. Now it is clearly of the form u plus iv. It is clearly of the form u plus iv. That means u is equal, the real part, sin x into cos hy, and v is equal cos x into sin hy. Now coming to the step number 2, we have to partial derivative. We have to find partial derivatives of u and v with respect to x and y. And first condition, single valued function is checking of single valued function not needed here because it is always single valued function. Okay, and partial derivatives we have to check. But for this type of functions, already we discussed partial derivatives of first order always exist. It is by default partial derivatives are exist. Now we have to check Cauchy-Riemann conditions only. For checking Cauchy-Riemann conditions, what we have to find? Dou by dou x, dou by dou y, dou by dou x, dou by right. So here our u is equal to sin x into cos hy. Our v is equal to cos x into sin hy. Okay, as you know that we are finding dou u by dou x, that is dou by dou x of sin x into cos hy. Sin x into cos hy. So we are doing with respect to x. Here cos hy is there. So taking out cos hy, do the differentiation for sin x. What is the differentiation of sin x? Just now we discussed it. Right. Cos x. Sin function differentiation is cos function. So sin x differentiation is cos x. Okay. Excuse me. So dou u by dou y, dou by dou y of sin x into cos hy. So taking out that sin x, because we are doing with respect to y, dou by dou y of cos hy. So sin x into cos function differentiation is, yes, cos hyperbolic or cos function differentiation is sin hyperbolic. But the difference is for cos hyperbolic it is plus, for sin hyperbolic it is plus. So for hyperbolic functions, cos and sin both are plus. For trigonometric functions, cos have minus and sin have plus sign. Please remember that. Okay. For trigonometric functions, sin x differentiation is cos x only. Cos x differentiation minus sin x. But in hyperbolic, both are positive. So here cos hy is there. So cos hy differentiation is plus sin hy. It is plus. Please remember that. So plus, there is no need of mentioning plus. If minus is there, you have to mention. But if it is plus, no need of mention plus. Okay, simply you can write it as sin hy. Clear? Now, dou v by dou x. Dou by dou x of cos x into sin hy. So take out that sin hy out into dou by dou x of cos x. So observe that it is trigonometric function, not hyperbolic function, cos x. So for the differentiation for cos x is minus sin x. Okay, clear? So minus sin x is the differentiation. So sin hy into cos x differentiation is minus sin x. So that minus sin x into sin hy. And dou v by dou y. Dou v by dou y is equal dou by dou y of cos x into sin hy. That is equal sin hy. Sin hy is the not a constant, cos x is the constant. So cos x you have to take out. Cos x into dou by dou y of sin hy. So dou by dou y of sin, in hyperbolic both are positive. So sin hy differentiation is only cos hy. So cos x into cos hy. Okay, so we have found dou u by dou x, dou u by dou y, and dou v by dou x, and dou v by dou y. Now we shall move to the step number 3. In step number 3, we have to check either dou u by dou x is equal to dou v by dou y or not. So if you observe here, dou u by dou x value is cos hy into cos x, dou v by dou y value is cos x into cos hy. So these two values are exactly equal. Now if you observe dou u by dou y sin x into sin hy, and dou v by dou x is minus sin x into sin hy. So these two values are exactly equal with opposite sign. So both conditions are satisfied here. So Cauchy-Riemann condition satisfied. By observing these four values, we clearly know that Cauchy-Riemann conditions are satisfied or not satisfied. So clearly satisfied, but according to the procedure, you have to write it down. Okay, in the step number 3. Okay, so ux equal to cos hy into cos x. So that is nothing but cos x into cos hy. That is clearly equal to vy. And uy is equal to sin x into sin hy, sin x into sin hy. So it is clearly equal to, already it is minus there, so we can write it as minus vy, minus into minus plus, okay, minus vx, sorry, minus vx. So CR conditions is satisfied. CR conditions satisfied. That implies f of z is equal to sin z is analytic function. F of z is equal to sin z. F of z is equal to sin z is analytic function. F of z is equal to sin z is analytic function. Okay, the extension question is if it is analytic, find the derivative also. So you have to do the differentiation with respect to z on both sides. So d by dz of f of z is equal to d by dz of sin z. So that is f dash z is equal to sin z differentiation is cos z. Okay, so this is the differentiation of. Right students, I am giving some similar type of problems as homework. So check f of z equal to z bar is analytic or not. Check fz is equal to cos z is analytic or not. Check fz equal to e power minus z is analytic or not. Okay, try to do these problems as homework. And with this one I am concluding this video. So we will discuss more problems of this kind in coming videos. Okay, so if you like my videos, please like, share and subscribe to my channel, and share the videos to needy students. Thank you all. Signing off, Sridhar.